Now, those are not the only two possible cost functions. Maybe what you care about especially is the false positives or the false negatives. How would you account for that? Let's say that the only thing that you care about is the false positives. What does a false positive mean? A false positive means that yi is equal to 0, but yi hat is equal to 1. Let's say that you only want to count the false positive. How would you transform those kinds of things into just counting the false positives? So here, like we said, you're counting the misclassifications, which means you're counting the false positives and the false negatives. How would you just count the false positives? Well, here is one possibility. You can still count the total number of misclassifications using r minus pi greater than 0.5, and then just summing everything up. Now, one possibility is you don't want to count the misclassifications. What you want to do is you want to count just those kinds of misclassifications, the misclassifications where yi is equal to 0. How would you do it? Well, this is the vector where if it's a misclassification, it's 1, and if it's not a misclassification, it's 0. So let's make misclassifications that are not like that be zeros as well. One way to do it is to multiply this vector by y, or rather r, because here y and r are the same thing, is equal to 0. Now, this vector is only 1 if there is a false positive. It's 0 otherwise. To be clear, this is a vector. So this is a vector of costs like that, except here the only possible cost where it's 1 is when you have a false positive. Now you can sum everything up. And what this will give you is the number of false positives. If you take the average, you'll get the number of false positives per example. This is not necessarily the best thing to compute. Probably it's best to just count up the number of false positives. If you know that a false positive costs you, for example, 12, you could multiply this number by 12 and get the cost where you pay 12 per each false positive.